Assalamu alaikum dear students, this is again Wajid Ali Shah explaining the topic AC through pair inductance, or simply we can call AC through inductor, which is given on page number 195 of the class 2nd year physics textbook. Dear students, what is an inductor? Inductor is actually a circuit element which resists the change in the current flowing through it because of the self-induction phenomenon or a back EMF concept. What is inductor? The circuit element are two terminal. One terminal is here, another is here. So, this is terminal A, terminal B. Circuit element which resist the change in the current. What are the properties of the current and the voltage whenever they are passing through the inductor? As we already have discussed this equation, which is a result of the Faraday's law of electromagnetic induction for self-induction. So EMF is equal to L delta I divided by delta T. EMF is a concept of voltage, L is a constant, self-inductance, delta used for change, I for current, and T for time. So the rate of change of the current in this inductor or coil gives us EMF. How that is possible? That is, we have already discussed in the previous lecture for electromagnetic induction. The main question here in this topic is that what are the properties of alternating current and alternating voltage whenever they are passing through the inductor? Inductor is normally consisting of a conductor such as a simple wire, conducting wire, and usually it is wounded into a coil, into a shape of the coil. Dear students, in this equation we have two important quantities: alternating voltage, alternating current. Which one is dependent, which one is independent? First of all, you have to choose this. So in this equation, as we know that the induction of the EMF depends upon the change of the current in the coil. So it means current is independent here. So we can write the equation for current. Instantaneous current is equal to maximum peak value of the current into sine of omega into t. You must remember this equation for alternating current. As the current is independent, so we can draw the phasor for the current like this along x-axis. As we know that x-axis is an independent axis, so we can draw all the independent quantities along x-axis. This is the phasor vector for current I. Now, through some mathematical steps, we are going to derive an equation for the alternating voltage. How? Let us do. We can change this EMF into V. For simplicity, for understanding, that we are actually dealing with the voltage, alternating voltage. So V is equal to L delta. Put the value of I here. I naught sine of omega t divided by delta t. This is equation 2. What we have done? We have simply put the value of the current from equation number 1 into this Faraday's law of electromagnetic induction. So, EMF is replaced by V just for simplicity, to give you a clear idea that we are dealing with a voltage in this form or in this form. L is a constant self-inductance, delta for change, and the value of the current is written I naught sine of omega t divided by delta t. This becomes equation 2. We can take this equation further, like V is equal to L I naught delta sine of omega t divided by delta t. Why we have taken this I naught outside? Because this represents the maximum value of the current, which is a constant, and delta does not apply on the constant value, so we can take it out of the bracket simply. And V is equal to L I naught. From calculus, we can write delta sine of omega t divided by delta t, the rate of change of sign of the function, gives us cos of omega t into omega. This is the subject of mathematics, class first year. And delta sine of omega t divided by delta t comes out to be cos of omega t into omega. Again, omega can be taken outside, Li naught into omega, cos of omega into t. This becomes equation 3. Now, as we know that I is equal to I naught sine of omega t, this is equation 2, previously written on the board. Now look at these two equations. V includes cos and I includes sine. Can we compare these two equations? Not at all. We can compare the equations only when we have the same trigonometric function. So we can replace this cos of omega t with another equation from calculus, from our previous knowledge, Li naught omega, like we can write sine of omega t plus pi over 2. This equation we can simply write like V is equal to V naught, which represents maximum value of the voltage, and sine of omega t plus 90. Pi over 2 is equal to 90. But actually we will be using the radian value, so we can change this 90 into pi over 2, because radian is the SI unit of angle. So pi over 2. Pi over 2 is equal to 90. Now we can compare these two equations, equation 2 and equation 4. Have a comparison of these two equations. And again look at the phase angle of the current and voltage. we can see that voltage is 90 angle more than the current. So the phasor vector for current was this I, and the phasor vector for the voltage will be this one. So this shows that voltage leads the current by 90 angle when it is passing through an inductor. And the graph should be that when the voltage is maximum here, that time the current should be 0. When the voltage decreases across the inductor, the current should be increasing and approaches maximum. Current maximum, voltage 0. When the voltage further increases and reversed, so current should also be coming to 0, like this. Voltage again 0, the current maximum. Voltage maximum, current 0. So voltage leads all the times. The current by how many angle? How much angle? By 90 angle. So this is the graph of the voltage and current passing through inductor. And along x-axis we should take time. Clear? Okay. That's all. Have a nice day. Allah Hafiz.